Okay, let's take a look at this problem. Let's find all the places the limit does not exist. So limit as x approaches a of f of x does not exist anytime the one-sided limits don't exist. So here at -4, the left-sided limit is 3, but the right-sided limit is -2. So that's at x equals -4. The limit doesn't exist. Same thing here at x equals 2. The left-hand limit is -1. The right-hand limit is 5. So by the definition of continuity, the function is not continuous at those points. And I'll write that in my list in a minute. Here, the limit does exist. The left-hand limit is 2. The right-hand limit is 2. That limit exists. This limit obviously exists. I mean, all of these, sometimes students get confused by this. At every point on these graphs, there's a solid dot. There's a solid dot everywhere. We just don't draw them all unless there's some ambiguity and we're not sure. Like here, they can't both be a solid dot or this would fail the vertical line test. So we emphasize, okay, just in case you weren't sure, the solid dot's on this one, not on that one. Or we'll draw a hole where there just isn't a solid dot. But then putting on that extra solid dot there, that's just, they're trying to confuse you. All of these points are solid dots. So nothing weird is going on here at x equals -1. Okay, so those are the places where the limit doesn't exist. Where is f not continuous? A function will be discontinuous if, or let's say it this way, 3 things have to happen. The function has to exist there. There's got to be a solid dot somewhere. The limit has to exist. And the limit and the function value have to be the same thing. Okay. So here, at these 2 points that we just mentioned, the limit doesn't even exist. You can see the function is not continuous. There's a big jump. So at -4, 2, the function's not continuous. Right here, the limit exists, but there's no function value. There's no solid dot anywhere. The function, there's a hole there. The function is not continuous at 4. Where does the derivative not exist? Any place the function is not continuous, if you fail this, you're done. The derivative does not exist. So same places in this particular graph. Now, what if we extend this graph a little? Maybe I put a sharp corner back here at -7. So that's supposed to be a sharp corner. Then the derivative would have problems right there. So I'm going to go ahead and add that on since I've extended my graph at -7. That derivative would not exist because of that sharp corner. We're still continuous. The limit would exist and all that. Or if we had an infinite tangent line, if the graph went straight up for even just for an instant, if the graph went straight up, the derivative would not exist. Any of those can break the derivative.